What's going on, everybody? My name is Mike.
And I'm Rory.
And this video is a quick setup guide for Actuonics stepper actuators. We're going to show you how to get started with an Actuonics stepper actuator, which is any model ending in -ST, using the TIC T825 stepper driver board, which is available in our store. Whether you're working with a P8 or an S20 model, this guide's going to help you get started.
Some of the common applications for our stepper actuators are robotic systems requiring precise positioning, optical equipment adjustment, diagnostic and testing equipment, industrial automation, applications requiring 100% duty cycle, and any application needing accurate, repeatable linear motion.
Now, what you're going to need to get started is an Actuonics stepper actuator. As I mentioned before, all of our stepper actuator models end in -ST. You're going to need a TIC T825 USB multi-interface stepper motor driver controller available in our store, as I mentioned, an Actuonics 12-volt power supply. The TIC requires a minimum of 8.5 volts DC. A computer for configuration, a USB cable, and our quick start guide PDF available on our website.
Some of the model-specific considerations you'll find for the P8 series, we have a 49 and 165:1 gear ratio. You can choose the 165 for higher forces or the 49 for higher speeds. The P8s have our smallest step sizes. The 49:1 is 0.006 millimeter, and the 165:1 is 0.0018 millimeter. Now you might choose the S20 series if that step size isn't as big of an issue for your application. It's still very small at 0.01 millimeter. These units use a little bit more power. They are 600 milliamps per phase, but you'll find they have a lower backlash than the P8 model since there's no gearbox in the S20, which can potentially give you a longer life due to the lack of gearbox, which can wear over time.
Now let's talk about basic setup. Step 1, wiring connections. We're going to connect the actuator to the TIC T825 board. For the P8 series, you're going to connect your orange wire, A positive, to A1. You're going to connect your red wire, A negative, to A2. Your black wire, B negative, to B2. And your brown wire, B positive, to B1. For the S20 series, you're going to connect your blue wire, A positive, to A1. Your red wire, A negative, to A2. Your black wire, B negative, to B2. And your green wire, B positive, to B1. Next, you're going to connect your 12-volt power supply to the TIC board. Don't plug the power supply into AC power yet. Your red wire, positive, is going to go to V. Your black wire, ground, is going to go to GND, or ground. Connect your USB between the TIC and the computer.
Your next step is going to be software setup and configuration. You're going to download and install the TIC Control Center software, and you're going to download the TIC T825 example configuration files zip folder from our Actuonics datasheet page on our website. Connect the TIC T825 via USB, plug your power supply into a 120-volt outlet, and start off with the initial configuration. Make sure you click de-energize in the software to ensure the motor is off during this configuration. Load the quick start configuration file for the model you have connected. It'll be in that zip folder that we just downloaded. Check that the current limit setting is correct for the actuator that you have connected. It is 256 milliamps for the P8 units and 600 for the S20s. Now there are 3 fields to fill in below the set position slider. Enter 0, 0. And in the third, the number of steps for full stroke. Refer to the quick start guide for the value that matches your actuator model length and type. Click apply settings. This will save all the settings that you've just made to the TIC control board. Remember to do this after any setting change or they won't be loaded. Click resume and move the position slider back and forth. The actuator shaft should now extend and retract accordingly.
Now we're going to talk about speed settings. Now that you've confirmed your wiring and basic configuration are working, your actuator's moving in and out, you can edit various values to customize the performance for your application. Refer to the quick start guide and the datasheet load curve to help determine the best setting values for the speed that you're trying to achieve. The values will vary with your selected microstep setting. Choose the microstep setting based on your desired speed. The datasheet load curve shows the setting we used when generating the load curves. For low speed operation, use 1/32 or 1/16 microstepping. This is great for precise positioning as well as quietest operation. For medium speed operation, you're going to use quarter step or full step. This is a good balance of speed and precision. while still maintaining good torque. For high-speed operation, we're going to use full step mode, enable ramped acceleration, monitor for missed steps.
For acceleration, we're going to check that the acceleration value does not exceed the maximum recommended, which you'll find on the Quick Start Guide chart. You can select a lower value if you want the actuator to move more smoothly. This causes the speed to ramp up and down as you make a movement.
Software interface features. The TIC Control Center offers real-time position control, 6 control interfaces, USB, TTL serial, I2C, analog voltage, quadrature encoder, and RC. For performance monitoring, you have current position, speed tracking, and error reporting. Customizable settings. Current limits. For power-sensitive applications, the current setting can be lowered to save power if the full performance isn't required. Step mode, acceleration profiles, and input conditioning.
This setting allows you to use the TIC without a computer. You can configure it to work like an RC servo, to extend and retract with an analog signal, or by connecting a quadrature type control knob. Some tips for success: start with the lower speeds and gradually increase, making sure you can complete a full stroke. Use microstepping for smooth, quiet operation. Enable acceleration ramping to reach higher speeds. Now you can monitor temperature during continuous operation. Operating temperature range can be improved by disabling the motor between movement. Actuator itself will hold position without power up to the backdrive force, which is given on the datasheet. Stay within 50 to 75% of maximum force rating. The additional load margin reduces the chance of missteps during repeated movements. Test thoroughly in your specific application.
And some quick troubleshooting steps. If the actuator isn't moving, first verify all connections. They could be loose, or the screw terminal could be clamped on the wire insulation rather than the metal of the wire itself. Check current limits in software. If it's below the rated value, the maximum output force will be reduced and performance won't match the datasheet value. Ensure proper acceleration settings. Check the Quick Start Guide for recommended values. You can try lower values. This will just reduce the average stroke speed to some degree. Monitor power supply voltage during movement. If the 12-volt supply is dropping more than a volt or two, try another supply to rule out any issue with the power supply. Look for error indicators in the software. Sometimes you might just have forgotten to click the resume button. Double check you've clicked the Apply Settings button after any parameter changes.
The TIC T825 provides flexible, precise control for both P8 and S20 actuators. Remember to choose your settings based on your specific model and application requirements. For detailed specification, technical support, and software, visit actuonics.com.
Thanks for watching. Catch us in the next one.